All right, good morning, everybody. Thank you for joining us. My name is Jason Long. I'm a sales engineer with Long Building Technologies here in Denver, Colorado. And we are joined today by Brian Levine, who's the Vice President of Sales and Marketing for the Clean Air Group and AtmosAir Solutions. Today, we'll be talking about data-driven air quality, industry-leading technology, controls, and monitoring. Brian, why don't you take us away here?
Thanks, Jason and Long team, for the opportunity to present today. We're going to keep it very succinct, 15 minutes. Hopefully, I'll be able to stand on one foot and deliver quality information with the hope and aspiration of hopefully sparking dialogue for future either lunch and learn presentations or just future dialogue. My name is Brian Levine. I've been with the Clean Air Group for about 8 years. We're out of Fairfield, Connecticut. We have a portfolio of air cleaning solutions, really under two brands that we go to market with. One being AtmosAir Solutions. You may have heard of that brand, or Bioclimatic Air Systems. AtmosAir really focuses on intelligent air treatment, as well as air quality monitoring. Bioclimatic comes to market with typical mechanical filters, electronic filters, UVGI technologies, needlepoint technologies, a number of different technologies. At the end of the day, we feel we're a market leader, and we want to be solution agnostic with contractors and engineers that we work with to essentially help owners achieve measurable impact, measurable results. We've been going at this market for about 4 decades now, nearly 40 years between both brands. Been fortunate to have a lot of market experience implementing technology throughout 320 plus million square feet. And I think a great statistic about Atmos and what we do is we've worked with 90% of the top 30 MEP consultants who are specifying our technology in new designs of renovation projects. Many of you have heard about bipolar ionization. I don't know if you've heard about an intelligent approach to it or an approach that revolves around our technology, which is dielectric barrier discharge. Essentially, we have patented air ionization tubes that live typically on the supply side of the mechanical system and essentially create positively and negatively charged ions. It's a controlled process that creates a non-thermal plasma discharge at our tubes, which is the creation of positively and negatively charged ions. The ions created off the tubes have a lifespan of 300 seconds, so they can transfer into an occupied space where they can interact with contaminants. It's a measurable, quantifiable technology. We're always looking to measure ionization rate along with a number of parameters of indoor air quality. You can see a controlled non-thermal plasma discharge on the right there off of our tubes. This is what the technology would look like in a pitch black air handler. But many of you have heard that BPI really comes along with 3 benefits. It's a dynamic, proactive, practical technology that essentially helps agglomerate particles, all airborne particles in an occupied space, in a duct, etc., carry a charge, as do all ions. The theory is that a positively charged air ion is going to marry up with a negatively charged particle and vice versa, creating an agglomeration or an attraction effect, making particles bigger, heavier, ultimately easier to capture on recirculation back to a filter or to displace from an occupied space. Secondly, it's been a proven technology, in my opinion, for reduction of odors via oxidation properties. We have the technology installed as an example in all the terminals at LAX airport to help control jet fuel related odors, a number of smoking casinos to help control smoke. Lastly, again, not a silver bullet at all, but a proactive approach to virus mitigation. We're looking to create, obviously, these positively and negatively charged ions that come out into an occupied space where transmission potentially can be happening, and obviously ultrafine particles can be floating that carry virus, etc. When superoxide ions, specifically negatively charged oxygen ions, come in contact with the crown protein or envelope on a virus, at that specific time, they convert into something called a hydroxyl radical, which is a powerful disinfectant. It has the ability to essentially penetrate the crown protein, pull hydrogen away from the cell wall of the protein, and essentially destroy envelopes and spikes to mitigate infection transmission. I love this slide. If you're checking this out on YouTube after the presentation, I like this slide because it's essentially the exact mechanism for disinfection per Dr. John Oxford, one of the world's leading virologists. So again, a dynamic technology that has not just one benefit like a mechanical filter, which we bring to market, which can catch and grab particles, but it can actually dynamically work against particles, gases, and viruses and bacteria. These are what our systems look like. Our largest systems I'm highlighting. A great benefit of this technology is it can treat large spaces. So we serve large bowl air handling units at some of our country's best arenas. And so we can scale up to 100,000 CFM plus. And it's typically, we're selecting our systems based on CFM, cubic feet of a space that we're serving, and type of venue. A great rule of thumb for what we do is that one 21-inch AtmosAir tube serves roughly 2,000 CFM of supply air, approximately 2,000 square feet in an office or school setting. It's an electronic air cleaning process, so it's powered off 120 or 240, our larger systems. Another great benefit relative to some other solutions is that energy consumption is close to negligible, 50 watts per unit, less than half an amp draw per unit, so it can piggyback off an existing 15 amp circuit and be pretty easily retrofitted into existing buildings. The technology is scalable, everything from a ceiling hung cassette, wall mounted cassette, fan coil unit, ducted fan coil unit. These are essentially smaller devices, what we call our fan coil series, AtmosAir FC400, that can be powered off 24 volts and leverage the existing power of a fan coil or smaller package unit. So we have different size systems with number of different tubes and size tubes to meet the rated capacity of the system that we're serving. We emphasize placement for efficacy downstream of final filters, downstream of coils, which can ground out bipolar ionization created off of the system. So either in a supply duct typically or in a discharge plenum, versus that's where we have put 95% of our installations versus being on the return side of the mechanical system or upstream of that infrastructure. It's where we've had most success. We've now implemented this technology, scaled it down to where it can be in a standalone air cleaner like our AtmosAir Everest, which has HEPA filtration, UV lights, and BPI, and a 200 CFM blower. We're seeing a big trend around increasing air changes per hour through standalone systems, specifically in school classrooms and office spaces. So scalable from everywhere from a standalone unit to an in-duct unit. Intelligent air treatment. What is that? To us, it's closed. I've heard people call it a lot of different things: closed loop technology, demand control technology. But we've developed Atmos Smart, which is an in-duct IAQ monitor. It can go in a return duct typically or in a return plenum. It measures 8 parameters of indoor air quality continuously: particle levels, VOCs, carbon dioxide, carbon monoxide, ozone, formaldehyde, temperature, and relative humidity. Communicates this IAQ data back to a building automation system over BACnet, IP, or BACnet over MSTP. A lot of people will ask, does the ionization system generate any byproducts, ozone, aldehydes, formaldehyde? I always say mitigate that conversation by putting in sensors that measure and validate and control the technology. And this is what Atmos Smart really does. We feel it's one of really the first of its kind in this space. It's been around for about almost 5 years now, so we've been able to perfect it and make it better. But it really is the control aspect of what we do and really closing the loop instead of just putting something in and hoping it works, really having measurement and verification behind it. We're also promoting what we call AtmosAir in-room or micro-level air quality monitoring systems. Typically, those go on a wall or on a ceiling, a device like so, basically the size of my hand, that's going to measure parameters of indoor air quality and essentially calculate an indoor air quality index. It's a great technology to complement the AtmosAir BPI technology, in addition to a lot of the other technologies that we're bringing to market, filters, et cetera. Taking it one step further, we're seeing net asset values of buildings increase, obviously with proactive IAQ technologies and measurement technologies. So we try to report this information and provide interactive and quality dashboards where a building manager, facility manager can see on their phone their IAQ, but also get a weekly report that essentially grades out their space relative to the time-weighted averages of the outdoor air quality. So IAQ reporting and transparency we see as a large trend here. I'm not going to really try to bore you with data, but hopefully this can spark more conversation for future sessions. We've just put a huge emphasis and focus on efficacy and data since we've started. We've executed 100 proof of concept projects and pilots with many really credible owners throughout the Americas and really globally. We've put the technology, we've submitted the technologies to different institutions. There's an ASHRAE funded research project that will come out soon that we just, that's been going on the past year that will have positive data. We have a lot of third-party tests and real-world tests, and we always try to look at kind of pre and post impact of the technology. How is the technology impacting particle levels, VOC levels, and then look at colony forming units of bacteria and spores, all while measuring fixed gases, ozone, aldehydes, et cetera. Something that people don't necessarily know, when we got started with ionization, Bioclimatic's been doing it quite a long time, probably 30 years, AtmosAir nearly 20 years. In the early 2000s, there was between 2 and 3 peer-reviewed studies on really what we do, BPI produced by dielectric barrier discharge and non-thermal plasmas. There's nearly 40 studies now, published studies on this technology, and I feel like we've done a decent job of putting together a strong reference list of these studies in academic journals, et cetera. Why do we do what we do? Hopefully improved human health and wellness. These are a lot of kind of third-party tests and controlled settings where we've looked at things like clean air delivery rate against 0.3 micron particles and how that equates to a MERV rating and a MERV 13 equivalency. At Syracuse University, studying the technology versus the 8 most common fixed gases or VOCs in a typical office building. So a lot of studies and test reports to share. And with just a few minutes left, I always try to leave our customers and clients and engineers with this information. I think this is the most important information that we can offer, which is we've been doing this for quite a while. As mentioned, 100 proof of concept projects and third-party data behind that. Sometimes people have tested our technology for over a year. We've subjected the technology to a number of different labs who have tested against a number of different contaminants of concern. We've tried to put together a strong reference list of peer-reviewed studies. We've taken it a step further by really putting measurement and verification behind what we do. We don't want to just necessarily put a black box technology out there. Controls, measurement, verification are a big part of what we do. We've seen great buy-in by the design community. And I think our case studies and testimonial speak for itself. We have a new website on our homepage, atmosair.com, that really has a number of end users and clients talking about our brand and our technologies. And it's nice to hear it not from the manufacturers themselves sometimes, but from the likes of the Empire State Building and Staples Center in Los Angeles and other really credible buildings. So with that, just wanted to thank Long for the opportunity to pitch our products for 15 minutes. And I know, Jason, you were going to end it with a couple of different things.
Yeah, thank you again, Brian. Thank you to everybody for joining us this morning. We know you're really busy. We appreciate your time. We invite you to join us again next week for the RayPack Advantage, what's new and what makes us better, with Josh Likes from Long. Thank you all again for joining us. Really appreciate your time. We'll see you next week.